Okay, this video is on covalent bonding 90% rules, and this is including bonding between nonmetals and nonmetals. So it's going to be on this side of the staircase. So it's going to be all these elements in here and hydrogen. So once again, I have the valence electrons along the top numbered in their columns. They're numbered in orange over there. And we'll look at something very simple, like fluorine. For example, fluorine, F, has 2, 4, 6, 7 valence electrons at 1s8. So if I look at the compound F2, which will consist of 2 fluorine molecules, each one has 7 electrons. Now how we did it with ionic was we transferred electrons. So I would get fluorine -1 and fluorine +1. This would be the fluoride ion, and I don't know the fluorine cation. This is not going to happen. It never happens between covalent compounds that are non-metal bonding. So what they do instead, put a big X through that, is they share. The fluorine with its 7 electrons is going to share with the other fluorine with its 7 electrons 1 electron. So when I count electrons, I will count 2, 4, 6, 8 electrons here, 2, 4, 6, and I double count this one in the middle, 8. So each fluorine looks at it as if it has 8 electrons. And so they're happy they've got the octet rule satisfied. All right, let's stop and try another one. So let's look at something like oxygen. Oxygen atom has 2, 4, 5, 6. So it wants to form. By the way, the dash represents 2 electrons here. This is always 2 electrons. You can use that anytime you want. So this is oxygen's going to want to form 2 bonds because it has 2 unpaired electrons. So in the 90% rules. So real rapidly we see this column forms 1 bond, this one is 2, this one is 3 bonds, and this column here for the nonmetals, remember, is 4 bonds. So those are our rules, 1, 2, 3, and 4. Hydrogen over here always forms 1 bond under the 90% rules. That gets us to helium electron configuration, or not 8, but 2. So helium's kind of an exception there. All right, let's look at this some more and do some compounds. So oxygen, O2, we have an oxygen with 6 electrons, and an oxygen down here with 6 electrons here. And we form bonds. Well, we can form 1 bond here and 1 bond here. Now this is a terrible drawing. I got to redraw it. Okay. But if I count my electrons, each oxygen has 2, 4, 6, 8. Oh, my pen's not working well, I'm sorry. And the other oxygen I'll do in red is 2, 4, 6, 8. What a mess. So we got to redraw this. We'll do it down here. Oxygen. We show that as a double bond to an oxygen. My pen's going to quit. And there's my extra electrons. So if you count the electrons on each oxygen, I'll do it once again. Here's 2, 4, 6, 8, 2, 4, 6, 8. That's because they're sharing these middle electrons.